Good morning, everybody. It's my pleasure to be here and share with you some thoughts about the industrial AI and especially the application in manufacturing, transport, etc. Then it's basically, as the moderator said, basically I'm an operation and maintenance guy, and I have come to the artificial intelligence is because we have been forced to do that, okay? This is all decision support systems in the industry have been powered by the artificial intelligence, and of course we have been forced to do so. Then in this aspect, actually I have been told that I cannot move so much, but I will do my best because I would like to be walking around, but I will do my best. The important thing for industrial AI is that we have to see that in the industry, so you have to think of industrial environments. The industrial AI is something in a big game where cloud, edge computing, and all kind of data repositories, data lakes, all kind of technologies and methodologies have come to the industry in the way of Industry 4.0. And Industry 4.0 is maybe the door opening for industrial AI. And in this regard, we have to be aware that the industry was not used to the artificial intelligence. We have to be aware that in the industry, in the history, we haven't trusted so much in the artificial intelligence due to lack of confidence on that. And I think now the paradigm is totally different. Suddenly, we have industrial process, we have transport, we have autonomous vehicles, we have robots powered by artificial intelligence, where the decisions are taken by algorithms. And this is extremely important because suddenly we find that the human in Industry 4.0 is no longer needed in the process. And this is very painful for the industry. You have to consider that in all over the world, but in Europe, we have created one industry that is basically based on human labor force, and suddenly we find that the artificial intelligence is something that from learning, reasoning, creation finally can take decisions and can automate many of the processes. And this is very important for us. It's important because, as some of the speakers, some of the keynotes said today, artificial intelligence is more than machine learning. We are not talking just about machine learning algorithms and how these algorithms can power and can improve the performance of some of our processes. Artificial intelligence is changing the way that we are working. And this is extremely important because artificial intelligence is almost a digital servitization of our processes. And in this regard, industrial AI is here for one reason. Industrial AI is here because we have in the industry, in the manufacturing actually, is the biggest producer of data that you can imagine. Nothing like social networks, Facebook, Twitter, financial data, nothing, forget it. The main producer is the industry, and the industry is powered by a lot of sensors that needs to be harvested the data, processed, and some decisions taken. And you can imagine, just for example here, you have one offshore platform. In this offshore platform, you may have 10,000 sensors. You cannot have humans to decide what to do with all the readings of these 10,000 sensors. But in the industry, we have one limitation. We have been talking about data-driven models for many years. We take data, and with this data, we create some kind of model, and we take some decisions. This is good. And we have been doing predictions for long. Industrial AI is not something that is doing predictions for predictive maintenance or wherever. This has been there for very long. What is different now? The difference is the services that we are creating and how far we are going. And how far we are going in the industry is maybe the main issue. It's maybe the main issue because if you go to the studies of the deployment of the industrial AI that you can find, in 2020, still we have a big limitation. It's painful, but we are talking about industrial AI a lot, and many of the projects that are in the industry still are some kind of pilots, case studies, or things like this. What it means is that in the industry, we have not succeeded in the deployment of the industrial AI. And why we have not succeeded? Because basically, we have not been able to tackle the unstructured data. In the industry, we have a lot of unstructured data. All the data is unstructured in the industry. We cannot have nice data. People complain about the quality, complain about many things. Forget it. Now what we have is something entirely different. We have unstructured data, and in the industry, people are not used to do that, and the scalability of the process has dramatically failed. We have to be aware of that. And in this regard, we have to be aware that when we put industrial AI on the table, what we want is to do some prediction. Prediction is the Achilles heel of the industrial AI. If I cannot predict the performance of my machines, if I cannot forecast my failures, then I have failed. And this is what we have to be aware when we talk about industrial AI. Industrial AI is also covering the whole life cycle of the data and the asset. When I talk about industrial AI, I want to help the designers and manufacturers. I want to help the customers. I want to help the operators, and I want to help even in the disposal phase. This is entirely different from social networks. You have to be aware that in social networks, we don't cover the whole life cycle of the machine. Actually, if you talk about industrial AI, is very much what the military people, they have been doing with the data. The military people, they have been integrating the manufacturers of the planes, for example, together with the users of the planes, and they have created a nice data life cycle where the data from cradle to grave is covered and processed. This is what we have to be aware in industrial AI. Industrial AI is something that has to cover the whole life cycle of the asset and the data. And in this regard, AI is everywhere in the life cycle of the data. Then we will see the difference between industrial AI and the AI for massive or for consumers, for customer satisfaction. When we talk about Amazon, Google, wherever, we know the services that we are trying to have, some segmentation, some prediction of the demand, etc. What we want in industrial AI? In industrial AI, what we want basically is predict the performance and forecast the failures, because what we want is a non-stopping industry. And this is what we want. Trains or airplanes that don't have any shutdown. Industries that they don't have any breakdown and can produce 24/7. What we want is that our industrial assets don't stop. And this is very, very important for us. These are the services that we are trying to power in the industrial AI. And the customers and the drivers are entirely different from the traditional ones that we are used. Of course, the players in the massive industry is Google, Amazon, etc. What is happening in the industry? In the industry, we have different players. We have General Electric, we have Siemens, we have the manufacturers like Airbus, Boeing, wherever. And these players are the end users, the guys that are doing the data ingestion of the data and taking information, extracting information out of that. This is actually extremely important, because we need to consider that in this part, in the industrial AI, there's a huge difference. The industrial AI, the data, is produced basically by machines. It's machine-generated data. It's not like Facebook, that you have data produced by humans. And this makes a huge difference. Then the industrial services are entirely different. The Google, Amazon, wherever, you try to forecast demand, you try to forecast some of your likes and dislikes, and try to segregate, cluster some people in groups, etc. Now in the industrial AI, what basically we want is to improve the productivity of our assets. As I said, in the transportation industry, we want reliable staff, non-stopping trains, planes, cars, etc., and same in the industry. In this aspect, we have to be aware that one important thing in the industry that will happen in the coming years is the social networks of machines. We cannot do by hand the analytics of everything for the machines. Now the idea is that we will have sooner or later we will have social networks of machines where one machine publishes in a blog or wherever the information, other machines learn what is interesting and populate this knowledge without any kind of human intervention. And this kind of learning, distributed learning, is very important because we are moving towards something that is very, very relevant. Where is going to be performed all the algorithms of the artificial intelligence? We have been talking about cloud for many years, but now we are moving towards something entirely different. When we talk about machines, industrial machines, we cannot have all machines transmitting all the data to a cloud. This collapses the cloud, this collapses everything. Now we are moving towards edge computing where the machines, where the components have some embedded intelligence and they are able to process the data that they collect. And this kind of mix, maybe in the coming years, we will have some mix. That is maybe the fog computing, where we will have a mix of cloud and edge computing. But definitely, the traditional view of artificial intelligence, where I take all the data, transfer all the data to a server, cloud, or wherever, and present all the data, this is no longer an option. It's no longer an option because where is going to be the process performed? We have to be aware that in the industry is very relevant because you may have thousands and thousands of assets. In some cases, you may have billions of sensors and millions of assets. And this is extremely relevant. Then, what options we have? One fully centralized system where all the data is transferred to a cloud. This is no longer an option. You cannot transfer all the data because we are collecting data with a sampling rate that is very high, thousands and thousands of sensors in any industrial asset, then definitely fully centralized is not an option. Semi-centralized maybe is more interesting. Semi-centralized, of course, if I have some assets that are semi-intelligent and some of the processing can be done in the edge, and just when something is happening you are transmitting this to the cloud, maybe this is an option. And definitely the option that in some cases is going to be the option taken is going to be fully decentralized decision systems. Why? Because we cannot neglect that now all suppliers are putting some intelligence in the device. You all have some kind of a smartphone and many other things with a processor and intelligence. Are you going to transfer everything to a cloud to be processed? No. Something will be processed in local, something will be processed in remote. And this is what we have to decide, what to do in local, what to do in remote, but think of industrial environment where you may have thousands and thousands of assets. That's why it's important that maybe the decentralized approach where you are processing something and not paying communication channels, you are not paying nothing of the processing in the cloud, etc., is relevant. And if you see the trend, you can see from 2016, the trend of cloud computing is going down dramatically. However, edge computing in the industry is increasing in the same ratio that cloud computing is decreasing. Why? Because now we cannot talk about assets that are stupid. We put some sensors and harvest all the data sent to a remote cloud. No, the asset itself has some embedded intelligence. And this is essential to make a rational use of their data and the communication channels, including the processing. Let me put one example. If you go to assets that are distributed all over the world, like for example, oil and gas or industry or wherever, what you cannot have is just connection from the sensors to the cloud and suddenly starts the transmission. This option is not an option. This is the traditional option. we sensorize, and then we transfer everything to the cloud. No, now we don't connect the data. We connect the solutions. What does it mean that I connect the solutions? What I do in the industry is very simple. What I do in the industry, I connect the different devices that have some intelligence. And these devices is my fleet. And this device, what they do basically is all of them, they have computing capabilities. All of them are training models. And what I do basically is, okay, I train my model, I improve my model, I predict my model, and then I share my model. Then what you are sending from the different assets to the cloud is not the data, is the model. You are sharing the model, and when you share a good model in one asset, the cloud or the central server or wherever is able to populate this among the whole fleet. But the computing capabilities are in the assets at edge, where you have not connected data, you have connected models. Connected models that, of course, are much lighter, you can transfer without any kind of problem, and definitely you are going to pay some kind of invoice much lower in terms of communication and in terms of infrastructure. And what to do, for example, in the industry at the edge? What to do at the edge? It's very simple. Imagine a number of assets transmitting a lot of data in terms of vibration, temperature, pressure, transmitting all the data. You are going to centralize all the data, process the data, and decide what to do with the data? No, definitely not. What you are going to do is, at the edge, you are going to do the pre-processing, noise reduction, feature extraction, and if something happens, then you transfer this to the cloud. But unless anything abnormal is happening, if you don't have any anomaly, for normality, I don't do anything. Then I save energy, because the energy consumption, especially when you have battery-driven assets many times, is very crucial, and I save bandwidth. And in this regard, it's very important, because if you have thousands of sensors, don't transfer normality, transfer just the anomalies. And if you transfer the anomalies, and you transfer also the models for anomaly detection, definitely you are going to be much more efficient, because you are going to have a disruptive methodology. You don't export the data, you train the model and export the model. And this model that you are exporting, when you have detected some anomaly, you are able to populate this model in a very, very nice way. And then you can populate this model in the whole fleet, and then you can obtain results with the rest of your fleet. But of course, I'm talking about Industry 4.0, and Industry 4.0 is complex. It's complex because we are removing humans. So far, it's very painful for the people when we talk about the fourth industrial revolution based on cyber-physical systems. But it's true that in the three previous industrial revolutions, the humans still played a very relevant role, and the technology was some kind of punch for them as a powerful tool. In this case, in the fourth industrial revolution, we have increased the complexity a lot, but we have to be aware that we are moving towards a concept that is called the dark factory. What is the dark factory? The dark factory is no light means no humans. Dark factory where operation and maintenance is performed by machines. And in these aspects, we have to be aware that having models to do predictions and take decisions in function of these models is not the fourth industrial revolution. The fourth industrial revolution is when you can let the machines take the decisions by themselves. This is the real Industry 4.0. Just having a number of people looking the screens and deciding what to do with the outputs of machine learning algorithms is not Industry 4.0. And this is where we have failed. We have failed because, as I said in some previous slides, the scalability of the process is not successful. In many companies, I have heard this sentence: I have more pilots than Lufthansa. What does it mean? In many companies, you are going to find many pilots developed by institutes, universities, wherever, to decide if the output of artificial intelligence is good. And the pilots are there forever. Never go for industrialization, never go for the whole company. Remain as pilots. And this is very painful. It's very painful because it's true that developing industrial AI and deploy industrial AI in industrial settings is difficult. It's difficult for many reasons. We have to play with legacy systems, all machines. Not all the machines that are in the companies now are very new and smart machines. No, we have a lot of legacy assets. All transportation systems, all manufacturing stuff, old, very old. And in this stuff, we have to struggle with the data. That is data from many sources, different granularity, different nature. In summary, difficult to deploy in the industry. And one important thing that we have found in the industry is that still there's a huge gap between the data science that are deploying models and the domain knowledge people. We haven't been able to succeed with this kind of marriage between the domain people who know about the machines, who know about the process, with the data scientists to co-create a solution. And this is for us maybe the main issue we have, because we need this understanding between the operation and maintenance guys and the data scientists. We need that. We need that because if we don't find the midpoint between the AI people and the domain people in the industry, we will not move forward. And this is something that we are putting a lot of efforts and we are failing. It's very sad, but we are failing on that. Why we are failing on that? Because let me be a bit not pessimistic, but is what is happening. In data science, still, we are putting most of our time to clean the data, to pre-process the data, and the value that is added by the artificial intelligence is still very few, because we are cleaning and pre-processing the data by hand before this data is ingested and then processed by some artificial intelligence. Then what does it mean? What does it mean? It means that I cannot see much on the data. It means that when I go for the services that I expect from my data, I'm getting a good nowcasting, that is looking back in the mirror. Okay, you have the data, this is what has happened, but you are telling me something that I already knew. And we are not getting forecasting. And as I said in the beginning, two services are the services that the industry is expecting from industrial AI. Is the prediction of the performance and the forecasting of the failures. And let me say why this is failing. Here you have one chart that is the degradation of one asset. If you are observing the asset always in this degradation, basically if you change, let me say in simple things, if you change, for example, the oil of your car every 10,000 kilometers, then you have always this kind of visibility of your data. The quality of your oil is always maximum 10,000 kilometers. But of course, you never run to failure your asset. You never forget about the oil and run your car up to 100,000 kilometers because you don't want to destroy your car. Then what happens? The data scientists can play in this area where they have data to explore, but they don't know about what is happening in the degradation that never happened. Basically, they don't know about failures that never happen. And in your data sets, if you don't have something, you are not going to be able to predict it. And this is what we call the black swans. If you don't have something in your data set, forget it. Even the best artificial intelligence will not be able to predict anything. And this is important. The data scientists cannot replace the domain engineers. They have to work together. They have to work together to co-create a solution where the data scientists understand the models and the domain, and the engineers, they understand the potential benefits of artificial intelligence. And then we will be able to save time. Because believe me, when I'm I'm working in any industrial AI project, and I see that this figure is more or less true, this figure that is more or less 80% of the time of the project is spent cleaning data, pre-processing data, understanding what to do, trying to make people understanding what to do, doing data analysis or pre-processing or cleaning by hand, very painful. Finally, what we get is one scenario where the green boxes is taking most of the time. The definition of the problem, the exploration, the cleaning, and finally, when you have spent most of the time cleaning the data by hand with heavy files, then you put the white boxes on duty, and then artificial intelligence comes into the picture. This is unacceptable. This is unacceptable because we are not efficient in that case. And never industrial AI will be successful if we are running our projects in this way. And of course, we are far away from the industrial AI that we want in the companies. Yes, sir. If you are now aware of the industrial AI in the companies, maybe we are between anomaly detection and failure classification, but very far away of forecasting, very far away of doing a real forecasting, and definitely extremely far away of deep learning. Then this is something that we have to be aware that is painful for us. And on top of that, I'm talking about failures, etc. But the industrial AI has to help us to identify invisible things. And this is what the industry doesn't understand. If you know that you have 10 failures and you want to predict these 10 failures, it's nice. But maybe you have 2 failures more that you don't know. And this is what artificial intelligence should help you with, to identify the invisible things. Of course, you have something that is happening and data that you are collecting and you can analyze this data. But you have many things happening in the back door that you can extract information out of that. And this is something, identify invisible things where the industrial AI can be extremely powerful. And this is what we call the digital butterfly effect in the industry. What is the digital butterfly effect? When you are playing in the industry with global suppliers, you have a lot of things happening in different parts of the world. For example, your machine that is running in US, maybe it was manufactured in Germany and one of the components was manufactured in China. And maybe something that is happening today in US is because something happened in the manufacturing process in China. And this is the digital butterfly effect. I'm able to identify in my complexity in a global supply chain where I have thousands of assets connected to different systems, in a global supply chain where you have car manufacturers that are having supply chains for asset supply chains, etc. Can I identify the root cause of something in the global supply chain? This is extremely important for me. If I'm able to do that with the industrial AI, then the industrial AI will be useful. And this is what I'm trying to identify. Yes, sir, I'm able to identify something, one event that has triggered in some part of the world and has created some chaos in a different part of the world. Because now we cannot talk about factories that are connected. The factories are connected. They are connected to the supply chains, are connected to the suppliers, are connected to everywhere. And then what is important is that if I have a loss of production, if my production suddenly drops down, I need to know why. And maybe the cause of this shut down is not in my factory, is in somewhere else in China or somewhere else in Germany or wherever. And this is important because the industrial AI can tackle different massive data, massive volumes of data that as a human I cannot. And the limitations of the humans in the industrial AI must be overtaken to identify root causes in very complex process. For example, when we talk about context awareness is something that is helping the industry a lot. What is context awareness in the industry? It's not about my process, it's about everything that surrounds my process. The geographical location, the operators, the culture, educational, social aspects, economical aspects. What do I mean? The same machine in India, UK, Mexico, US, or Spain behaves totally different. What I want to know is why. And the industrial AI should help me to identify why my machines, my assets are behaving in a different way in different parts of the world, in different time zones, or in different time shifts. And in this regard, what is important is that we have to see that the industrial AI is the evolution of the cyber-physical systems. In the industry, we have been talking about cyber-physical systems, CPS, for many years as the main drivers of the fourth industrial revolution. Now, we are talking about something else. What we are talking about is about the cyber-physical system as the platform where industrial AI is going to make a disruptive change in our technology. And in this regard, we have to be aware that the service we are expecting in the industry is the cognition. We cannot be in the Stone Age anymore in the industry. What we have to be aware now is that in the analytics that we are expecting in the industry, cognition is the only option we may have. Why cognition? If you look the evolution of the analytics, and industrial AI has to be there. What we can accept is that we have been doing descriptive analytics for very long. We have been looking back in the mirror, and it's very nice. Okay, a failure happened, and then we find one explanation why the failure happened. This is descriptive analytics. This is looking back in the mirror. It's not acceptable anymore. What we have to be aware is that the timeline of technologies in the industry is entirely different. Now we are in the border of 2020. Definitely industrial AI, together with some other technologies, side technologies like cybersecurity, etc., will be the key technology. Why? Because we are not transforming the industry. It's not a transformative revolution. It's a disruptive revolution, what we have to do with artificial intelligence. And why is a disruptive evolution? Because from industrial AI, what we are expecting is something else than this. In the past, 3-4 years ago, we were talking this evolution from description to prescription. And we were quite satisfied with the prescription. What does it mean? Let me summarize. Description, looking back in the mirror, this is nothing. You are just telling me what has happened. Diagnostic analytics, okay, to find the failures, to identify what is going wrong, but I don't know when it's going to fail. Predictive, okay, we were very satisfied with predictive. We will know when it's going to fail. And prescriptive, let me know what to do to make it fail when I want, know when the machine is going to shut down. This is okay, but now we are moving to cognitive analytics. And what does it mean in the industry, cognitive analytics? Cognitive analytics basically is, okay, remove the human from the decision support. One human cannot visualize the output of the algorithms when you are talking about thousands and thousands of algorithms giving outputs continuously about what to do. We have to rely on the machines, and the machines have to take the decisions. And for that, we have to trust on the machines. Because if we go for descriptive analytics, what is descriptive? Descriptive is what we are doing now. Very sad, let me say. A descriptive analytics is, I have this data, then I have two groups of data, and okay, this is descriptive. I can identify two groups of data. I don't know what is going on there, but I have two groups of data. What is diagnostic analytics? Diagnostic analytics is something else. It's something like, okay, I have two groups of data, and I can identify where is each group. Each group, the blue one, is healthy, the red one is failure number X. Okay, then we can go one step ahead. Predictive analytics. Okay, predictive analytics is I have these groups and I can predict when the blue dots will move to the red area. And then I can predict the remaining useful life of my assets, and then I can even do some clustering there. This is very nice. I'm able to predict when it's going to happen. But what happens here? One step ahead, the prescription. What does it mean, the prescription in the industry? The prescription in the industry is very simple. When you have one asset that is, let's say, one machine, and you are operating the machine in a soft mood, then the degradation is slower. If you are operating the machine very hard, degradation is faster. Then, okay, the remaining useful life of the machine depends on the operational profile. Tell me what you want to do in terms of mission, and I will tell you the operational profile, the best one to achieve the remaining useful life you want. Basically is, let me what you want to do, and I will tell you what is the remaining useful life that you are going to have. But of course, depends on the operational profile. And finally, cognitive analytics is the biggest step. And the biggest step is, okay, I'm telling my machines that my priority is maximize the production and minimize, for example, the consumption of the energy. And with these two parameters, I let the machine decide which operational profile is optimum for the machine. This is the way forward when we are talking about cognitive analytics. Cognitive analytics is when we are moving from the prescriptive analytics and we let the machine, based on a cost function or operational criteria or whatever, moving towards some kind of decision system. And in this regard, in artificial intelligence, our tool is the digital twin. Yes, sir, when we are talking about artificial intelligence in the industry, basically the engineering model that we are using with all the data coming from the field and the models created there, when we do that, whatever is the digital twin. We are twinning the reality. We are twinning the reality because what we are is incorporating models that are harvesting the data and trying to predict, like a crystal ball, what is going to happen, when is going to happen, and take the proper decision. And in this regard, we have to be aware that the digital twin is a model where the engine is the industrial AI, where the inputs are all the data of our assets, and the outcomes are the expectations that we have created in terms of prediction and prescription. The digital twin is not a 3D model. This is something very fashion sometimes, but the digital twin is the engineering model powered by industrial AI that is able to take the decisions that are going to be mirrored in the real assets. And this digital twin is the co-creation between the data scientists and the engineers. The co-creation of these both groups, the engineers that have been in the industry for decades and the data scientists that have come into the picture. Because together, this co-creation is going to deliver the digital twin as a model to predict different things. Actually, in manufacturing, when we talk about digital twin, I will not be very long in that because I'm running out of time, but basically, when the industrial AI is powering a digital twin where both OT and IT get together is when the digital twin is successful. And this is one of the main issues of the industry. What is OT? You know, operational technologies close to the asset, PLC, sensors, etc. IT, managerial staff, ERPs, etc. When you can merge both, and when the industrial AI can bridge the gap between AT and OT, then we can create the first digital twin, because at the end of the day, the digital twin is the IT and OT convergence powered by industrial AI and powered, in this case, also by the models. But we have to be aware of one more thing. We have talked about OT and IT. And OT is the operational technology close to the asset. IT is the technology that is in the managerial level. But IT and OT are lacking one important thing. The ET, the engineering technology, that is the domain knowledge, means that you have the data that you are collecting from the field, the data that you have in your IT systems, OT and IT, and the engineering technology are the models. And then these models basically is the evolution of the digital twin from traditional simulations to real digital twins. When the moment we can transfer the traditional simulation and we power these simulations with real data, basically simulation with coming from the design and manufacturing, with real data coming from the field, bridging the gap between OT and IT, then we will be able to create the digital twins for analytics. And this is what now we call functional mockups. Functional mockups that are these small components where we are twinning different components, different parts of the reality, and delivering different services. In summary, what we have basically is now the challenge of industrial AI in terms of take this to the market. And for that, as I said, of course I will be happy to answer any question later, but as I said, it's important to packetize the aspects. Just let me finish. In summary, let me say that we have to be focused on delivery, scale our models, and definitely move one step forward in order to go from pilots to industrialized models. Thank you very much.